Alright guys, let's get started with decimal basics. First thing we're going to talk about is base 10 blocks, and you probably have used these a lot in your school career. And typically, this flat here always stood for 100. This rod is going to stand for 10, and a unit cube is going to stand for 1 whole. So let's write the names of those in, because that's not going to change. So we have a flat, a rod, unit cube. Sometimes we just call it a unit, or sometimes just a cube. And then we have this guy over here that you may have handled, you may not have. We're going to call this a sliver. Sliver of something is usually slice a thin sheet off of it. And if you look at this, you can see that if we took this unit cube and sliced it, it would look a lot like that. And that's where it comes from. Okay, now I want you to forget everything you've learned in math before today. Well, not everything, but some of it. We're not going to think about this as just 100 every time over here. The flat and the rod's not going to always be 10. The unit cube is not going to be 1 all the time. Sometimes it will be. It just kind of depends. But we're going to kind of adjust our thinking a little bit here. So we have a decimal point here. So if the decimal point's right here, what place value should be over here? Should be the ones place. Directly to the right of the decimal point is going to be the tenths place. Moving another spot over, we're going to have the hundredths place. And in the third spot, moving to the right of the decimal, we have the thousandths place. Emphasis on the THS at the end. Thousandths. You'll notice that everything to the right of the decimal is going to have that THS at the end. That kind of tells you we're talking about these little things less than 1. Okay, and over here, so just to give us a number, this is going to be 1 whole. This would be 1/10. This would be 1/100th. And finally 1,000th. Okay. And if you look at the way that is organized, it kind of follows a predictable pattern. You can see that it just moves 1 spot farther away from the decimal. And if you think about whole numbers, it does the same thing. We just don't always put that decimal right there. In fact, you've been kind of doing this since kindergarten. We just haven't been using a decimal point all the time. So another thing I want you to observe about this is that it kind of is a place value chart. This would be like kind of the headers of a place value chart. If I drew vertical lines in between this, you could write numbers below each one and organize your numbers in that way. And we'll be doing a lot of that. So let's look at this now. This flat is 1 whole. Now, maybe thinking, Mr. Steiner, that's wrong. This a flat should be 100. Well, here's the thing. 1 whole just refers to 1 complete set of something. So if we had a 1,000-piece puzzle and we had all the pieces, that would be 1 puzzle, right? Now, not all puzzles have 1,000 pieces. Sometimes they have 10 pieces. Sometimes they have 100 pieces. They might have 500 pieces. They might have 37 pieces. It just kind of depends. But everything I just described would be 1 complete puzzle. So 1 can mean many things. Think about other things that can be 1 whole thing. And it is not always going to be the same thing. So in this case, we're going to kind of use this flat to represent 1 whole set, okay, of just units. And the reason we do that is because it's easy to divide this up into smaller pieces. So if we take this one whole and chop it into 10 pieces going down vertically, you end up with a bunch of rods, right? Specifically 10 rods. And one of those rods would be 1/10 of a set, 1/10 of a whole. Okay, we can keep doing that. This unit cube, which it says is zoomed in, that would come from just one of those. Okay, and the sliver would be like taking this unit cube and literally just slicing off the top, provided that you could do that 10 times or have 10 pieces. Okay, so those are the base 10 blocks that we're going to use with decimals. And you can kind of see that once we get out to the thousands place, it's starting to get to the point where physically handling base 10 is getting kind of difficult. Because those slivers, you can kind of picture how small that would be, and that would get tedious to count all those. That's why it's kind of easy to just, if we have 10 of these, we can group them into a cube, and that's easier to count. If we have 10 hundredths, we can group them into groups of 10 to make a tenth, and then take tenths, group them into groups of 10 to make a whole. Money is a very great tool to kind of understand decimals. So this would be like $1. This would be like a dime. So let's draw a dollar in right here. Here's my photorealistic dollar. Don't turn me in for forging money. Okay, here's our dime. Again, photorealistic dime. Here's our penny. And then we get over here to the thousands place, and what coin is going to be a thousandth? Yeah, it doesn't get one. And that's the only problem with using money in decimals, is that it's great until we get to the thousands place. There is no thousandths coin. Okay, a penny is not worth very much, so taking the value of a penny and chopping it into 10 pieces is worth almost nothing. So we've never had a coin, even at the beginning of our country when a penny was worth something. I'm not going to do it. So feel free to use money if that helps, but just know that you're going to have to kind of really think about that hard when we're jumping from a hundredth, 1 penny, to a thousandth, because we don't have a coin that transfers. All right, let's move along, and let's start looking at word to standard form. So word is just the way you're going to say the number out loud. Standard is just the number itself. So don't get tripped up on all these definitions and stuff. Word is just the spoken form. Standard is just the number. Okay, so the only time you use the word and, okay, the word and, when you're reading a number, is when a decimal point or fraction is involved. Okay, so we're not talking about fractions today. We'll get to that, but we are talking about decimals. So I want you to come back up here real quick, and I want you to write the word and wherever you have room. And we're only going to say this word when you see a decimal point. You don't want to say it anywhere else. Even when you have whole numbers, you don't say it, which a lot of people do. Even adults do that. And is the only time you use and is when we have a decimal point. Okay, so we got that. When converting, or fractions, when converting decimals, always start right and work your way left. Guys, this is the opposite of the way we normally work. Even when I'm reading this, I'm starting on the left side and working right. We're going to go from the right and work our way left. Place value charts are really helpful with decimals. Get used to making place value charts, guys. They don't take very much time. Okay, very, very helpful. Okay, so here's a couple of examples. We have 4 in the ones place, decimal point, so we say 4, and there are no tenths, so we don't say 0 tenths, we ignore it. Okay, it's important, it needs to be there. We can't delete it, we can't erase it, because if that wasn't there, this 2 is going to be in the wrong spot. This 2 goes out to the hundredths place, so this is 4 and, nothing there, 2 hundredths. Okay, we have a bigger number here. So we go out to the thousands place here. And a lot of people like to put and sometimes here, sometimes they'd like to say 983. Don't do that, it's wrong. Okay, here we go. 1,983. And now we can say that. 25. I'm going to say it's all as one number. But where does it go out to? It goes out to the hundreds place. So it's going to be 2,500. So 1,983 and 25 hundredths. Okay. So let's take a look at this. We're going to go real slow together and convert this 12 thousandths here. So first step is we need to go out to what place value for this number. Well, it says it right there, the thousandths place, right? So write that in. Got to go out to the thousandths place. The reason I know that is because I'm looking at the word form. It tells me. So guys, this is something I want you to get in the habit of doing. Okay, now I provided this for you today, but when we're making decimals in a minute here, I want you to start drawing in these little blanks for yourself out to whatever place value it tells you to go to. Okay, so we know we have to go to the thousands place, so we have these blanks drawn in. Step 2, start placing digits in your blanks, starting from, do we remember which way we go? Do we go left to right? No, we do not. Okay, we go, lost my pen. Right to left. So I'm going to start on the right side, which is this one right here, 12. I'm sorry, the 2 and the 12 is on the right side, so I'm going to put the 2 right there. Okay, that's all it's saying. We're going to start on the right side of both numbers, original one and where I'm putting it in the correct place value spot. Okay, step 3. Okay, before I do that, I'm going to put that 2 down I already put. Step 3, continue with the next digit. The 1 will go in the what place value? Well, could I sneak it in here? No, we cannot ever have 2 digits in a single place value. It's not allowed. You will get arrested by the math police. So I'm going to continue. The 1 will go here. And what place value is that? Yes, it is going to be in the tenths, hundredths place. Let's write that. Hundredths place. Okay. Good. Okay, let me copy what I have down here. So I have a 2 right there, 1 right there. Be sure to include placeholder zeros to keep everything in the right, you can say spot, or more correctly, place value. So guys, if I leave this as it is, this would be 0 here, 0.12. But I cannot leave it that way. There's a reason why we drew these blanks in. Because this 12 needs to go to the thousandths place. If I just ignore this space here, this 12 will not go out to the 10th, 100th, thousandths place. It will go only to the 10th, 100th place. So I gotta put a placeholder 0 so it keeps those numbers in the correct spot. Okay, and you can put a 0 here too. It's not going to change anything. It's just saying we have 0 ones, so 0 holes. And there's our number, 12 thousandths, looks like that. Okay, let's do 1 together. Down in the bottom section of the first page. Okay, now we're going to do what we just did above. 64 hundredths. So I'm going to put a decimal point. And I know I need to go to the hundredths place. So I'm thinking decimal point, 10th, 100th. So make sure you draw those spaces in. You can put something for the ones place if you want. It won't change anything. Okay, the main thing is that we get the decimal to the correct spot. So just to show you an example, before I put anything in here, the way I would set up the one directly below it it says I'm going to the thousands place. Guys, I don't even care what this number is right now. I just want to know the place value. So, tenth, hundredth, thousandth. Okay, we can set up the next one down below. Tenth, so I only got to go out one spot. Okay, so let's try this. 64, all of these are 64 somethings, 64 hundredths, so I'm going to start on the right side. The 4 goes here. 6 goes there. I'm going to have a 0 there. Okay, right here, 64 thousandths. I'm going to put a all the way to the right, 4 there, 6 there. I need a placeholder 0 here. Again, I can put something in the, I'm going to have a 0 there in the ones place, just to remind myself I have no holes. Okay, 64 tenths. Okay, well, here's my tenths place. So I'm going to put a 4 here. Uh-oh, I'm out of spots. Maybe I should just squeeze that in. No, if I do that, then it's going to be identical to this one up here. And 64 hundredths is definitely not the same as 64 tenths. It always spills into the next place value. It does not matter if there's a decimal point there. So just like when you're adding and you get something more than 10, okay, 6 plus 5 is 11. You'll put your 1 down and you'll carry the 10. So it's going to go to the next place value. So let's make another place value here, the ones place. So 64, I have the 4 down, the 6 goes here. So the answer would be 6.4 for that one. So 64 tenths is the same as 6.4. If you want to relate this to money, tenths is like a dime. So 64 dimes would be $6.40. You could add a 0 here. Okay, and also that's a very quick way to count up coins if you're trying to do that, is put it in something like this and it becomes a very recognizable number. Okay, so you can pause the video here and go ahead and work these next 3, and then we will continue on page 2. Okay, let's look up at page 2. Now we're going to do the opposite of what we just did. We're going to go from standard number form to word form. Okay, so let's start here. We'll do a couple of these together. So on my whole number side, I'm going to read that as a number first. So I have just 6, so I'm going to write 6. I have a decimal point. What word is that? And. Now I'm going to look at everything to the right of the decimal altogether. There's only one digit there. That is a 7. And it's 7 in the tenths place. So 7. Tenths. So I kind of look at this as 2 separate phrases or words, depending on what you have. I look at the whole numbers on the left and the decimals on the right, and I connect them with the word and when there's a decimal point. Okay. So let's go ahead and look at the one directly below it. So we have 6. That's the only whole numbers I have. So it's going to start out the same. Have a decimal point and. Okay, now I have the number 70 on this side. Okay, and 70 goes out to the tenths hundredths place. 1, 2 spots. So it's going to be 70 hundredths. Now, something kind of interesting about these 2 numbers. Okay, anyone have an idea what that is? You can pause if anyone has an idea. They are equivalent. They are equivalent. Okay, they have the same value, even though they're said in a different way. But let's think about what this is. Now, the 6 is the same, and is the same. We have 7 tenths and 70 hundredths. So 7 tenths would be like 7 dimes. 70 hundredths, that would be like 70 pennies. So if I had 7 dimes and 70 pennies, and I went to the store and I needed to buy something that was 70 cents, I could use either of those options. They're worth the same thing. So just a different way to represent the same value. In fact, if I came over here and added a 0 here, would I really be changing anything? Not really. I'm just saying I have 0 hundredths, right? So that's not changing anything. That would be like putting a 0 in here. Sorry. That would be saying I have 0 tens, 0 $10 bills. Okay, so go ahead and pause the video here and take a moment to fill out the rest of this. Okay, let's check out expanded notation. Expanded notation is kind of a way to explain the value of each place value. Not just the place value, but in that specific number. Okay, so I kind of told you at the beginning, place value charts help. If you had a place value chart, we could put this in the place value chart, 2.584. I said that way on purpose because I don't want to talk about place value at the moment. But we would take the 2 and then we put it in the ones place. I want you to look at that. 2 is in the ones place, so it's 2 times 1. Okay. 5, we go in the tenths place, so it's 5 tenths. That's how many tenths we have. So we have a tenth 5 times. That's what that means. And we keep on following that pattern. We have 8 hundredths. So how many hundredths we have? And 4 thousandths. So this down here below is going to be your expanded notation. It's the standard form up here. Just a regular old number. Notice that we have a plus sign in between to link it all together, because if you multiplied all this stuff out, 2 times 1 is just 2, right? 5 times 1/10 is 5 tenths. 8 hundredths, 4 thousandths. If you added it all together, you would get this number. Okay, so let's try that down below. Okay, so standard form, just regular number, to expanded notation. So let's try a different number. These are the same numbers as above, so let's skip down and I'm just going to do one of these with you. Let's do this one right here. 17 and 34 hundredths. So I'm doing expanded notation, so I'm going to do each place value individually. Okay, so this 1, so the first thing is we have 1 of something. What is that something? That's in the tens place, so it's going to be just 1 times 10. Okay. Since this number does not go to the thousands place, I'm going to use money to kind of describe this. So it's like one $10 bill. Okay, we have 7 next. 7, and this is in the ones place, so it's like $1 bill, so it's just 7 times 1. Okay, next I have 3 of something. I have something 3 times. So 3 in the tenths place, so I'm going to write 1/10. This is just telling me I have 3 tenths. And then I have a 4, and that 4 is in the hundredths place. So the hundredths, 100th, and I have 4 of them. Okay, so guys, I started on the left with the largest place value, whatever it is, and I worked my way to the right and continued. So however many digits you have, that's how many you should that's how many of these little parentheses and multiplication problems you should have in your expanded notation. Now, one little trick that I want to tell you about before you start on your own is that if you have a 0, you do not have to put that in expanded notation. So we would do the 5, we would do the 6, we do the 7. If you have 0, well, 0 times the hundredths place, 0 times 1/100th is going to be 0. It's a waste of writing. You do not have to put that in. So just leave it blank. So this one would have only 3 of these little chunks here to add together. Okay, so that wraps up decimal basics. I will leave you on your own to finish out this section. Enjoy.